This video is an introduction to isomers. It's for Year 11 level, but if you're in Year 12 and you're starting Chapter 10, then it's good to look at this to start with. Isomers are molecules which have the same molecular formula, for example C7H16, but their carbon atoms and the hydrogen atoms are arranged. There are different ways of arranging them. Okay, there are 4 different sorts of isomers, different ways you can arrange atoms. So this video is only looking at the chain isomers with alkanes at the moment. For Year 11 we have to do positional with alkenes. I'll do another video on these. And for Year 12 we have to look again at alkanes, but substituted alkanes, and these we'll look at alkenes again. So these are stereoisomers, and we do them in Year 12. So we're just looking at alkanes and chain isomers, and you need to know how to do the structural formula, the semi-structural formula, and their names. The molecular formula, obviously, you can't build on anything from that. So we're going to have to be able to move from, if you're given any of these, the name, or the structural formula, or the semi-structural formula, you need to be able to find out the other bits of information. Okay, so for some revision from the last video, what is the name of this? This is a structural formula of a hydrocarbon, an alkane. What's its name? Can you write its semi-structural formula, and can you write its molecular formula? Okay, so you count that it has 7 carbons, and the name for a hydrocarbon with 7 carbons is heptane. If you do the semi-structural formula, it's CH3, CH2, 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 and then CH3 on the end. The molecular formula is C7, there's 7 of them. If you double that, it's 14, plus the 2 for the ends, makes it 16. Okay, so now we're going to look at how you work out branched isomers of C7H16. So different ways of putting the 7 carbons together, apart from in a straight chain. So on the previous slide we looked at the straight chain isomer of this. Now we're going to look at branched isomers. For working this out, we're just going to look at the carbons and draw the carbons, different ways of putting the carbons together. Once the carbons are together, you can add the hydrogens around them. So if you do it systematically, if you take a carbon off one end and put it somewhere else, so if you were to put it on the first carbon, basically what you've made is the same thing. You've made a chain that's exactly the same as this. You've just drawn it differently. So when you take the carbon off the end, you can't put it on either end, because then you're just basically making exactly the same molecule as at the top. So if we set it on here, we've made a totally different molecule. What would be the name of this molecule? Okay, so I've added the hydrogens. You need to always add your hydrogens. And each carbon has 4 bonds, so there's 3 hydrogens on this carbon down here. When you're naming a branched isomer, the first thing you have to do is find the longest chain. So one carbon after another, find the longest chain and circle that so you know where that is. Okay, and the first thing you do, you do your name backwards. So the name at the end is the name of the longest chain. So in this case we've got 6 carbons, so the name for an alkane with 6 carbons is hexane. Then you have to number the chain so that any groups hanging off it are on the smallest number. So if we numbered this number 1 and that number 2, that's lower than if we went from here, 1, 2, 3, 4, 5. Okay, so you number from the end, that gives you the smallest number. This group hanging off it has 1 carbon. So we use a prefix. The beginning of the word is the same as methane for 1, so it's the same as meth, But instead of saying methane, we say methyl. So this is a methyl group. And that methyl group is on the second carbon. So it's 2-methyl to show that it's on the second carbon. So that's an isomer of C7H16, a branched isomer. Okay, so we need to do the semi-structural formula for this. We work our way along the carbon chain. So the first carbon has CH3. I've done this carbon here in orange so you can see what's going on. This carbon has a hydrogen attached to it and this methyl group. So we put the methyl group in brackets, so it's a CH3 methyl group. And then CH2, CH2, till CH3 at the end. So all of this here is attached to that carbon. What would be the name of this branched isomer of C4H16? I've moved the methyl group onto the next carbon. So it would be just 3-methylhexane. Can you move the methyl group onto this carbon? Would that make a different isomer? If you think about it, if you got this molecule and you turned it over, if you have that, it's the same molecule flipped over. So that's not a different isomer if you put it here. It's the same isomer as that one. So be really careful how you draw, that you're not drawing the same molecule different ways. So if you drew it up here, that would be the same isomer. If you drew it over here, that would be the same isomer. So systematically, the first thing we did was take one off the end and try it in various positions along the middle. Now, and we found that we could do that for and make 2 different molecules. Now we'll take 2 off the end so that we've got 5 left, and we'll put the 2 in various positions in the middle. So we could put 2, one on either side of this second carbon. So we would have a methyl group at the top and a methyl group at the bottom. What would that be called? You notice I haven't put all our hydrogens in here, so from now on I'll just be looking at the carbons, but on an exam or a test you must make sure that you fill in all the hydrogens. So don't be lazy like I am. Okay, so when we name it, we do the same as you always do. You find the longest chain. So the longest chain has 5 carbons on it. And you name the longest chain first. So the name for a 5-carbon hydrocarbon is pentane. Then you put all the bits and pieces that are hanging off that chain. You name it at the front. So there's 2 methyl groups. So you need to say dimethyl. I've highlighted that because that's a common mistake. People remember to do the numbers, but they'll forget the di. So there's 2 methyl groups, but you need to say which carbon they're on. So both of them are on the second carbon. So the second mistake people do is they go 2, and they only do that once. They don't do this other 2. So it's 2,2-dimethylpentane. So the semi-structural formula, I filled in the hydrogens. Semi-structural formula, you work your way along the main chain. So we've got CH3, that's the first carbon. So the first carbon. Then the second carbon, the one in the middle, it's got 2 CH3s attached to it. So this second carbon has CH3 twice. Then we work our way along the chain, CH2, CH2, CH3. So each of these carbons is the carbon along the main chain. So you've got 1, 2, 3, 4, 5. And then any bits and pieces hanging off it, you write after that carbon. If they're a collection, or if there's a couple of different things hanging off it, you can put them in brackets. So if you wrote CH3 in there without the brackets, it would be very confusing. So instead of having the methyl groups both on the same carbon, we could move this methyl group along, so it's on the 3rd carbon, or we could move it along so it's on the 4th carbon. When you're trying to work out how to put them together, it's probably easier to do this really simple setup with just the carbons. So you arrange the carbons so that they're in different places, and then you fill in all your hydrogens. So hydrogens all around, so that each carbon has 4 bonds. If you counted up all of the hydrogens for any of these molecules, you would find that you had 16. Okay, so some of the alkane subscripts. Di means 2, so you've got 2 of the same group, or 3 of the same group, or 4 of the same group. If your group has 1 carbon, then it's a methyl. If it has 2 carbons, it's ethyl. 3 carbons, propyl. Okay, so this is a complex looking branched isomer. Can you pause this and see if you can name it? I haven't drawn any hydrogens on, I've just drawn little lines to show hydrogens, just to try and keep it simpler. Okay, so the first thing that you need to do is find the longest chain. So if you're tempted to draw the chain around here, just remember that I could write that, these carbons here, I could put them out here, and then it would be the same molecule. Okay, so if I bent it round and drew it here, then this whole line is straight. And if we go up the other end here, I could either draw that one down and have a molecule this long, the chain, the main chain, or I could draw these 2 up here and have it longer. So if we were to find the longest straight chain, 1 carbon after another, then you would find that really this is the longest chain. So the longest chain has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons in it. So the name for 10 carbons is decane. So we can write the end of our name. So what we need to do is work out, do we number them from 1, 2, 3, or do we number this 1, 2, 3? So we have to look at all the groups that we have hanging off our main chain and see if we can get the lowest combination number. So if we numbered them from here, 1, 2, 3, 4, 5, 6, then we would have a 3, 5, and 6 being the carbon numbers that our groups are on. If we went from this direction, we would have 1, 2, 3, 4, 5, 6, 7, 8. So clearly we need to go from this direction to get the lowest numbers. Okay. If we have a look, we have 3 methyl groups. So we have methyl. And the prefix for 3, 1, 2, 3, is tri. So we have trimethyl. Our trimethyl are on 1, 2, 3. One of them is on the 3rd carbon, and the other 2, 4, 5. The other 2 are on the 5th carbons. So we have 3, 5, 5 trimethyl. Okay, so that's going to be one of the names at the front. The other groups that we have 2 carbons in them. So the prefix when you have 2 carbons hanging off a chain is ethyl. So we have 1, 2, 3, 4, 5, 6. They're both on the 6. So we've got 6, 6, and because we've got 2 ethyl groups, the prefix for 2 is di. So we have diethyl. Now you're probably wondering why I haven't just written it 3,5,5-trimethyl 6,6-diethyl decane. Why didn't I just write it in the line? So the thing is, when we've got multiple groups at the front, we put the multiple groups in alphabetical order. So we're looking at this to work out the alphabetical order, not the tri or the di. So E comes before M, so it's 6,6-diethyl 3,5,5-trimethyl decane. Okay. So you notice when you write it out, you put commas between the numbers, and then a dash between the numbers and the prefix. A dash, 3,5,5 with commas, then another dash, trimethyl, nothing here, decane. Ane because it's an alkane and it's saturated, it has single bonds between the carbons, single carbon-carbon bonds. Okay, so as well as just having carbon and hydrogen for alkanes, we can have halo alkanes. So we can substitute, the word is swap, a hydrogen for a halogen. So halogens are in the second last group on the periodic table. They want one more electron, so they form one bond, just like hydrogen. So wherever you would normally put a hydrogen, you can put a fluorine, a chlorine, an iodine, or a bromine. The prefix, instead of methyl for one carbon being substituted, the prefix would be fluoro, chloro, iodo, and bromo. Okay, last one. So see if you can find the longest chain. So if we have a look, if we start here and go all the way up, instead of going across, if we go down, we get the longest chain that way, which means that this is a methyl group hanging off it, and we have two bromines, so two bromos, and a fluorine, so a fluoro group. So we need to know which way to number it. So if we went from this direction, it would be 1, 2, 3, 4, 5. So it would be 5, 6, 7 are all of the carbons that have a group on them. So if we went from this direction, this would be 1, 2, 3, 4. So the numbers would be much smaller. So we'll number it from this direction. So we have 2 bromo, so we have a dibromo, and the dibromo is on 2 and 4, so it's 2, 4 dibromo. We have a fluoro group on the 3rd carbon, and we have 1 carbon, we have a methyl group on the 4th carbon. So our main name, 1, 2, 3, 4, 5, 6, 7, 8. 8. We have 8 carbons, so the name for 8 is octane, which I need to write further over because it's going to be so much other writing. So octane. So alphabetically, this is M, B, and F. So B, F, and M, B. So we start 2, 4, dibromo, 3, fluoro, 4, methyl. So B, F, and M, octane.